Today we're going to talk about the laws of exponents. These are also called exponent properties or exponent rules. Let's start with the product rule. If you have some number a to the power of x times a to the power of y, since the bases are the same, they're both a, that means this expression is equivalent to a to the power of x plus y. For example, if we had 2 squared multiplied by 2 cubed, that would be the same as having 2 cubed times 2 squared, or 2 squared times 2 cubed, and you can see that that equals 2 to the power of 5, which is 2 plus 3. And we can only say this because the bases are both equal to 2. Now, what if we have a to the x over a to the power of y? This is the quotient rule, which states that a to the x over a to the y is equal to a to the power of x minus y. To illustrate this, we can use similar numbers. If we had 2 cubed over 2 squared, and we write out all the 2's, you can see that some of the 2's cancel out, and we're left with 2 to the power of 1, which is the same as 2. But you can see that 1 equals 3 minus 2. Now, what if we have some number a to the power of x to the power of y? This is going to be equivalent to a times the product of x times y. And this is the power of a power rule. To illustrate, if we have 2 squared all cubed, that's going to equal, let's see, 2 times 2 cubed, which is the same as saying 2 times 2 times 2 times 2 times 2 times 2. This is 1 time, this is 2 times, and this is 3 times. And you can see that this equals 2 to the power of 6, which is the same as 2 to the power of 2 times 3. Now, what if we have something different inside the parentheses? What if we had the product of 2 numbers, a times b, all to the power of x? Well, the power of a product rule states that this is equivalent to a to the x times b to the x. You can kind of think of it as the exponent applying to every term inside the parentheses. Usually, when we're turning this form into this form, we don't know what's inside the parentheses, which is why we need to spread them out like this in order to solve some kind of algebraic equation. However, just to prove that this law works, let's say we knew that a is equal to 2 and b was equal to 3. If we had all that cubed, or squared, sorry, then we could see that that's the same as saying 2 times 3 times 2 times 3, which is the same as 2 squared times 3 squared. Now, if we had a quotient inside the parentheses, a over b all to the power of x would equal a to the x over b to the x. So similar to the power of a product rule, this power of a quotient rule kind of applies the exponent x to both terms inside the parentheses. And just to illustrate this, if we had, let's say, a equals 2 and b equals 3 and x equals 2, this would be the same as saying 2 over 3 times 2 over 3, which is equivalent to saying 2 squared over 3 squared. Now, if we had some number a to the power of 0, that's going to equal 1. If you're curious about why, feel free to check out a different video explaining this. If you're interested, I can make one, so let me know in the comments. If our exponent is some negative number, x, then a to the negative x is equivalent to 1 over a to the power of x. So essentially the inverse, where the exponent is the opposite sign. This might look a little confusing, so let's go through an example. If we had 2 to the power of negative 3, that would be equivalent to 1 over 2 cubed. Likewise, if we had some number like 5 to the power of negative 27, you would know that that is equivalent to 1 over 5 to the power of 27. Remember to switch this negative to a positive, because if you don't, then you'll get a wrong answer. And the last law of exponents is the fractional exponent rule, which states that if you have some number a to the power of some fraction x over y, then that is equal to some y root of a to x. Now this one is a little confusing as well, so for an example, if we had, say, 2 to the power of 2 over 3, we're gonna take the denominator and make that the root, so this would be a cube root, and then the inside would be the base and the numerator, so this would be 2 squared. And another thing is that a to the power of x inside the y root is equivalent to saying a to the y root all to the power of x. These two are the same. So if we look at our example, we could also say that 2 to the 2/3 power equals the cube root of 2 squared. These are both the same. Let's look at another example just to make sure we got this. If we had some number, let's say 7 to the 5/8 power. I know these are weird numbers, but let's say this is the problem. That's going to be equivalent to 7 to the 5th power inside the 8 root, whatever it's called for 8. So that's it for this video. I hope that you learned a little more about exponent rules. If you have any questions or suggestions, please leave them down in the comments below. Thanks for watching.